Hi, my name is Jenna Bakandi, and today I'll be going over section 12.3. Section 12.3, similar triangles. This is a concept we should already be familiar with, but we're going to review today. Remember, this is about an object or shape being similar in proportion, not necessarily the same size. First, let's review congruency of a triangle. Two triangles are considered congruent if their corresponding sides are equal in length and their corresponding angles are also equal in measure. Otherwise, meaning that they will have exactly the same three sides and exactly the same three angles, neither depending on whether or not they are the same proportion. So angle A would equal angle D of another triangle, or side AB would be equal or congruent to DE of another triangle, etc. These are examples of congruency. Showing congruency. Now we have these two triangles to show you how we can use the equal sides and angles to show congruency. Now if we have three of the same angles, so we would have to say that angle A would be equal to angle D. So angle A would be congruent to angle D. Now to say that these are similar triangles, all three angles would have to be the same. So if angle A equals angle D, that would mean that angle B would be equal to angle E. So if we're trying to show that these two angles are the same, A and D, you'll have 1 mark. And if you're trying to show B and E are the same, you need to put 2 marks. Now, we can assume that if angle A equals angle D and angle B equals angle E, that angle C would correspond to angle F. So we would show congruency by putting 3 marks. So angle B is congruent to angle C, or I'm sorry, angle E, and angle C would be congruent or equal to angle F. Now we're trying to show congruency. So if something is congruent, that means that all three sides and all three angles are going to be equal. So we've already shown how all three angles are equal. Now we're going to show the sides. So if we want to show how the sides correspond to each other, here's an example. We would have side DE would be equal to the same as A over B. So that means DE's side would be equal to the same as side as A and B. Now we could also show this by saying that side EF is the same as side BC. And we can also put it that side DF is also equal to side AC. And to show that these are equal, we could put 1 mark to show that A and B is equal to DE, 2 marks to show that BC is equal to EF, and 3 marks to show that FD or DF is equal to AC or CA. And that's how you can show congruency by markings. And also another thing that we use when we're showing congruency this way is all three angles of the side, or all three angles are the same. This is using the AAA or AA similarity property, which would be called angle similarity property, which we'll review in a moment. This other way we're showing congruency is by showing that they have 3 equal sides. And this is using the SSS or side similarity property, which we've previously reviewed. Now I want to do a quick review of some property rules that we'd previously gone over, just so we could see how we could use them for similarity tests for triangles. First, I want to go over the AAA or angle similarity property rule that I previously mentioned. This rule states that if all 3 angles in one triangle are the same as the corresponding angles in another triangle, then these triangles are similar. Now for the SSS or side similarity property, this rule states if all 3 pairs of corresponding sides of true triangles are proportional, then the two triangles are then similar. You can see that I have an example as well for two triangles with similar angles and two triangles with similar sides. Ratios and proportions. I want to review ratios and proportions and how we could use their similarities to prove what a missing side or possibly an angle might be. Now, a ratio is a comparison of two quantities. Now, proportion is an equality of those two ratios. So for this first problem, we have two triangles that are considered similar. For these two sides, we have 9 and 36 that are corresponding, and 6 and A. Now for this problem, we want to try to find A. So if we want to compare ratios, 9 would be the same as 36, because they're corresponding sides, as 6 would be to A. Now to solve this, we can cross multiply. So 9 times A would equal 9A equal to 6 times 36. And if you do that calculation, that equals 216. If you just divide 216 and 9A divided by 9, you get A equals 24. So your missing side would equal 24. And that's how you can use some ratios and proportions to find the sides of a missing side for a similar triangle. Let's do another one. So for this example, we have two triangles that are different sizes but are proportional and similar. So for this first triangle, we have side 7 that corresponds to side 21 on the other triangle, and side B that corresponds to 15 on the other triangle. So we're trying to find side B. So if we use our ratios and proportions that we just reviewed, 7 would correspond to 21, and 15 would correspond to B. Now, in this case, we could either cross multiply or we could use rational thinking to say that 7 goes into 21 3 times, and what goes into 15 3 times would be 5. So, to test this theory, instead of using inductive reasoning, we're going to go ahead and do the cross multiplication. So 7 times 15 would equal 105, and 21 times B would be 21B, and if we divide both sides by 21, B would be equal to 5. So our inductive reasoning earlier for rationalizing this to 5 would be correct. So our missing side would be 5. And that's another way of using ratios and proportions, and a different way to find that missing side. Now I'd like to do a short review on missing angles. Now, when we talk about congruency, when we have two different triangles with two similar angles, or a similar angle, or we can also refer to that angle-angle property, we can assume that they are similar, and we can use these properties to find the missing angles. So for this instance, we'll call it triangle 1 and triangle 2. So for triangle 1, we see that we have one angle of 70 degrees and another of 40 degrees. Now, obviously, we know that there is 180 degrees in a triangle. So we can go ahead and use our brain or a calculator, whichever you prefer, and calculate this, because 70 and 40 would be 110 degrees. So if there's 180 degrees in a triangle, we can deduct this and say that there is 70 degrees left over, so A would be 70 degrees. Now remember, we're trying to also prove that these triangles are similar or congruent. We have already established that A is 70 degrees, so we can already show and prove that these two triangles are congruent because they have two similar angles, 70 and 70 and 70 and 70 degrees. So if we want to go ahead and just pop in this other angle, we can already deduct that B would be 40 degrees. To prove this, we could say 70 degrees plus 70 degrees would be 140 degrees, and 180 minus 140 would be 40 degrees. So A is 70 degrees, B is 40 degrees, and we could say that these two triangles are similar and that all three angles are congruent. And we can also deduct from this that all three sides will also be either proportional or the same. Elfin, that sums up my short review of section 12.3, similar triangles. I hope you have a wonderful day. Bye-bye.